So at the onset of this project, we were trying to create an aerodynamic road helmet. Some of the challenges that we had was taking a look at this new form of a helmet and looking at how are we going to get airflow to pass through this helmet so the rider stays relatively cool, but also meet the design goal to have an aerodynamic helmet.
We really had to rethink the shape of the helmet. We wanted something much more compact, something that would be more wearable for a longer period of time.
When you're racing a bike, most of the power you're putting out is being used to overcome aerodynamic drag. So anything we can do to shave some drag is going to reduce your power consumption. Traditionally, aero helmets have tried to follow a teardrop section concept, and what we've discovered here is that you don't necessarily need that long tail in order to improve the aerodynamics of the head.
And that's how we ended up with the shape with the AirTac. It has a similar frontal area as a time trial helmet, but as the air flows over the back, we were able to truncate back the helmet, and the air still thinks it's flowing around a long wing-shaped helmet, but it's not. The other neat technology that we are starting to look at would be thermodynamics. As a rider heats up, that can start to affect the performance. So Giro pioneered the use of measuring thermal heat in a head form called the Therminator. What that does is allows us to heat up the head form to human temperature. Then we place thermocouples all around the outside, and we can actually map out areas of the head that are cooler or hotter. And that informs us where vents are working or vents aren't working. So how do we get air to come into a helmet without having to open up huge vents? And we've achieved that through a new fit system.
The unique thing about this fit system is that it is the head form now, so it's a much more secure, much more comforting fit.
As air hits the rider, there's a very high pressure zone right at their forehead. If we can capture that air, that rider's head will be cooler. So we have a fit system that suspends the rider's head off of the EPS, and then the large channels allows whatever air comes in through this 3mm opening to have many ways to exit. So as air comes in, it's going to pass up over the top of your head and right out the back.
One way to visualize that flow is to pop the helmet into the water and then use dye injection to see how the flow will infiltrate the various ventilation passages and how it comes out.
I think one of the other neat things about the helmet is the shield attachment. That was a big challenge in itself.
There's 3 magnets in the shield and there's 3 magnets in the EPS. The best thing about this magnetic anchoring is you could have this in your back pocket and ride without it, and then when you decide you need it, is to come up and slip it into place, and it locates and finds itself automatically. And then if you decide you don't need it and you don't want to put it back in your pocket, it'll dock backwards on the helmet. It's not going to fall off. It's not going to go anywhere.
From a summary standpoint, I think we achieved our goals of aerodynamics. We achieved our goals for helmet cooling. And I think our weight is right where it needs to be. We have made the most efficient helmet.
Sort of the Swiss Army knife of helmets. It fills a new niche.
This is a helmet that anybody could really wear. I'm really excited to say that I worked on it, and it's going to be great to see it in the tour this year.